Good morning. This is your stats sensei, Mr. Spensey, and we are going to do an exit ticket on our intro to hypothesis testing. So the EPA requires that the mean exhaust emissions for a certain car size to have no more than 1.45 grams of nitrous oxide per mile. A car manufacturer claims their process reduces the mean level emitted by their cars. A simple random sample of 33, so we have N is 33. Is taken, and the mean level exhaust emitted for this sample is 1.27. So our X bar is 1.27. It is known that the exhaust emissions are skewed right and have a standard deviation of 0.54. All right, skewed right is bad, but because we have a sample size 33, we're normal by central limit theorem, so we're okay to proceed. All right, it says write the null and alternative hypothesis. Well, let's do that. Well, we need a claim. Well, we have to use as the status quo as our claim. We never use the sample mean. It's always the population mean. Well, they didn't specify one exactly. They didn't specify it exactly, but no more than 145. So the claim is, or the status quo, I should say, is 1.45 grams. And I know it says no more, but we're going to always use an equal for our null hypothesis. For alternative, their claim is, the car company claims that it's less. So our mean is going to be less than 1.45 grams. All right. We need to define our parameter. So our parameter is let mu equal the true population mean amount of nitrous oxide. All right. And really that's from the new car, but it's a, so we'll go ahead and add that for the new process. All right. So now we know what it is. The next thing it says, so we've write the null and alternative. Now we're going to define the parameter. We did that. Run the test using an alpha of 0.05. All right, that's going to be important. I'm going to note that down. So this is going to be a z-test. So z equals x bar minus mu, the standard deviation, divided by the square root of n. We know our picture is going to be 1.45 is the population mean, but we got a sample mean of 1.27. This is x bar, this is 1.27. We're shading this way. We need to get our labels, label our material, what goes in. The mean is 1.45. The standard deviation, it does not need a line on it. Standard deviation happens to be 0.54. The x bar is 1.27, and in this case was, what did we use? N is 33. And we're shading also to the left. So we're going to look for the probability that Z is less than 1.27. I'm not going to have enough room in there. I'm going to scoot over here and do it over here. Probability that Z is less than 1.27 minus 1.45 over 0.54 divided by the square root of 33. This is going to be a z-test. Stat test, z-test. Mean is 1.45. Standard deviation is 10. X bar is 120 or is 1.27. N is 33. And we need a less than. We calculate, and we end up getting a Z of negative 0.1. So the probability of Z is less than negative 0.10 equals 0.4588. And check that real quickly. Stat, test, Z test, everything match up. Standard deviation was wrong, 0.54. Excuse me. And we end up with a negative 1.9148. So this is the probability that Z is less than negative 1.9148, and that equals 0.0277. All right. So our decision, it says write the conclusion. We're not going to write the conclusion. We're just going to say their decision. Our p-value and our alpha. Our p-value is 0.0277. Our alpha, they said, was 0.05. Make them the same length. This is less. So we're going to reject the null. All right, so our decision is to reject the null. If we were to write our conclusion, it would look something like this. Our p-value is, now I'm not requiring you all do that because we don't have room, but our p-value is 0.0277. We reject the null. There is, the word I use is sufficient. There is sufficient. And that just means there's enough evidence at alpha equal 0.05 to suggest that this is where we're going to restate our parameter. True population mean amount of nitrous oxide for the new process is less than, we need to look at what we claimed. Process is less than 1.45 grams. All right. So that would basically be running the entire test with the exception of stating our conditions. Appreciate you watching. Hope to see you on the next one.